So we're going to talk about graphing polar coordinate equations. And so one of the things that is important with this is actually knowing if your graph has symmetry. It's really normal for a graph to have symmetry. So where we're going to start is first we're just going to talk about what does symmetry look like for polar graphs when we're graphing them in the xy plane, the Cartesian xy plane. So the tests for this are a little bit different. So for instance, if I have symmetry about the x-axis, okay, so what that means is if r theta lies on the graph, then either r negative theta or negative r pi minus theta lie on the graph. For symmetry about the y-axis, if r theta lies on the graph, then r pi minus theta or negative r negative theta lies on the graph. And then finally, symmetry about the origin. So if r theta is on the graph, then negative r theta or r theta plus pi lies on the graph. So to summarize all of this, so if I have r theta on my original graph, so for the x-axis, I need to have r negative theta or negative r pi minus theta. Symmetry about the y-axis, r pi minus theta or negative r negative theta. Symmetry about the origin, negative r theta or r theta plus pi. So the thing with these being ors is that this means that one or the other has to hold. So it's possible that one might not hold and the other will hold. And so this actually kind of creates a situation where you have to check both. Okay, so let's take a look at just how do I identify symmetries in general. So I've got two graphs here, so we're just going to go through and do this. So let's start with r equals 2 plus sine theta. Okay, so using my handy dandy little list here, so first I'm going to check r negative theta. So I'm going to replace, so for my x-axis, I'm going to replace my theta with a negative theta. And so now really what I want to see is if I use my trig identities, can I get back to the original equation? And in this case, I know sine of negative theta, that is equivalent to negative sine theta. These two things are equal. And as you can see, this equation does not match this equation because this is negative and this is positive. So this one didn't work. And ergo, I now have to test the next condition, which will be negative r and pi minus theta. So now I replace r with negative r. My theta becomes pi minus theta. Okay, and so here, now we are going to have to think about some of our other trig identities. So these identities here are going to be possibly very useful when you're going through this. So specifically, in this case, I need to use this sine of a minus b. And so if I plug this in, so you're going to end up with sine of pi, and sine of pi is going to equal 0. So I'm just left with the second part of this identity. So I'm just jumping to that part just so that you know. So what I'm left with is when I use that identity here, so I have negative r equals 2 minus sine negative theta cosine of pi. So now you have to just kind of think through all your signs here. So I have this negative and this negative will cancel out based on my trig identity, but then this will turn into another negative. So what I get is this side becomes negative r equals 2 minus sine theta. And if I divide everything by negative 1, I will get r equals negative 2 plus sine theta. So this does not equal this. Therefore, we do not have symmetry about the x-axis. Okay, now, if you don't have symmetry about one axis, then you can't have symmetry about the origin. So symmetry about the origin means that you're symmetric about both the x and y axis. So this actually now rules out some things that we have to test. So now I'm going to move on to the y-axis. And so remember, so for the y-axis, so now what I need to check is r pi minus theta. So we will start there. So I plug in pi minus theta in for my theta. And once again, I'm going to go ahead and use, I'm going to use these identities here. So if I plug these in, what I'm left with is 2 minus cosine pi sine theta. And so in plugging these in, what I get is that r equals 2 plus sine theta. Now, this is an or. So as long as one of these hold, then you have that symmetry. So you don't have to test both. It's just as long as one holds, then you're good to go. So I now have found that this, plugging this in, got me back to my original equation. And so what that means in this case is that it's symmetric about the y-axis. But since it's not symmetric about the x-axis, it will not be symmetric about the origin, so I don't have to test anything else. Okay, so let's try that again for r squared equals sine theta. Okay, so let's start with x-axis symmetry, and we're starting with r squared equals sine of negative theta. And so we can see right away, right, so this will be r squared equals negative sine theta, so this will not work. Okay, so what I want to encourage you to do now is I want to encourage you to actually evaluate the other test for symmetry. And just take a second, I showed you those identities, all that good stuff. So I would recommend that you set this up, and you can either pause here, or I'll show you the identities right here and you can pause here. So try plugging these in and seeing if you can go through this all the way just to make sure that it makes sense to you, and then hit play when you're ready. Okay, so I am plugging in my identity. So when I plug in my identity, I end up with sine of pi, and sine of pi is 0. So the first half of that long identity goes away. And so the second half of this identity just becomes negative cosine pi sine of theta. And of course, negative r squared just gets us back to r squared. Okay, so this is a negative, and cosine of pi is -1. So a negative and a negative is going to end up giving me r squared equals sine theta. So I have now proven that this is symmetric about the x-axis because one of these two conditions held. So this is symmetric about the x-axis. Okay, so now let's pivot to the y-axis. And so once again, I would recommend that maybe you just, well, actually, if you look at this, right, this is very similar to what we just had before. So I'm left with, once again, this r squared equals negative cosine pi sine theta. And so then, yeah, I'm left with r squared equals sine theta. So I can see right away that this is also symmetric about the y-axis. So if I'm symmetric about the x and y-axis, then immediately what that means is that I am symmetric about the origin. And so I'm symmetric about all of those things. So you usually don't have to test for symmetry about the origin if you're testing for your symmetry about the x and y axis. Or I guess the other way that you could go, the other way that you could think about this, if we go back to our list, you could start by testing for symmetry about the origin. If you get that it's symmetric about the origin, then it's symmetric about these other two. So it's kind of up to you which direction you want to go with this. I usually just like to kind of rule things out, but you can do you. Okay. So cool. So now let's talk about how to find the slope of a polar curve in the xy plane. So you're going to use this formula. This is pretty straightforward. So you're going to ideally have some sort of polar equation, r equals something in terms of theta. And so you're going to have r prime of theta sine of theta plus r of theta cosine of theta over r prime of theta cosine of theta minus r prime of theta sine of theta. So I think it's actually easiest if we just jump into an example. So let's find the slope of the curve at the given points. So I'm going to have r equals -1 plus sine theta at theta equals 0 and pi. Okay, so let's give ourselves a little bit of space. And so really, we just need to have this formula in front of us. So this is the formula that I need to follow. And so you can see from here, you're going to obviously need to know what r prime is. So here's my original function. So let's go ahead and just kind of write this out. So I have r prime, this is just going to equal cosine theta, right? Okay, so from here, now I need to know just some different values. So I'm going to write maybe all of these over here. So let's start with like theta equals 0. So at theta equals 0, r of 0 will be, so if I plug in 0, I have just -1 plus sine of 0, which is 0. So r of 0 will equal -1. And r prime of 0 will equal, so cosine of 0 is 1. Okay, so there's my first one. And then if I use theta equals pi, so r of pi in this case will still equal -1, and r prime of pi will equal -1. So here's everything that I really need to like plug into this. So now let's go ahead and do this. So let's start with theta equals 0. So at theta equals 0, I'm going to have, let's see, this is going to be -1 sine of 0 plus -1 cosine of 0. And then this will be over 1 cosine of 0 minus -1 sine of 0. Okay, and so if I just evaluate these different pieces, so let's see, I'll put a little arrow over here. So this is going to come out to -1 over, looks like 1. So that's just going to equal -1. So when theta equals 0, my m will be equal to -1, my slope at that value, okay? And so that's all we're being asked to do with this. So let's clear some space and let's do it again. So now I'm going to do this for theta equals pi, and I'm just going to follow the formula again. So I have r prime of theta, so that's going to be -1 times sine of pi plus, let's see, this will be -1 times cosine of pi. And then in the denominator, this will be -1 cosine of pi plus -1 sine of pi. So if I calculate all of that, in this case, I'm going to get 1 over 1, and so I just get 1. And so when theta equals pi, my m will equal 1. So that's how you figure out your slope at a particular value of theta in this situation. Okay, and the last thing that we've got to talk about now is how do you graph a polar equation in the Cartesian xy plane. So what we're going to do for this is, first we're going to flip the plane. So I'm going to graph r equals f of theta, but I'm not going to graph it on the xy plane. I'm going to graph it in the r theta plane. So this is going to be kind of a fun thing to think about. And then I'll use that graph to make a table of points to guide the sketch in the xy plane. So let's use the graph r equals 2 plus sine theta. Okay, so first of all, remember sine theta, this is going to be between -1 and 1. So between these two values, right? So the highest value that this is going to get is going to be 2 plus 1, so that's going to be 3. And the lowest value will be 2 minus 1, so that's between 1. Okay, so I want to remember that because that's what r is going to equal. So that's going to help me set up this r theta plane. So what I'm going to do is I'm going to call this side r and I'm going to call this side theta. And so I've just marked this from 0 to 3. Okay, so in creating this new plane, this might make the graph a little bit easier to draw because now I can also set up a couple different values of theta. So for instance, I could have, let's see, let's just choose a few easy points to work with. So I'll have theta over 2, or sorry, pi over 2, pi, 3 pi over 4. And let's see, I'll extend this a little bit. So I'll call this 2 pi. Okay, so here are my different values of theta. So if I start plugging these in, so at 0, this will just be 2. At pi over 2, so at pi over 2, sine of pi over 2 is 1. So this will be up to 3, so this will be 2 plus 1. If I plug in pi, this will get me back to 2. And then if I plug in 3 pi over 4, that'll get me -1, so it'll be down here, and then I'll come back here. So what I can see is I have a graph on this r theta axis that kind of works like this. But also look at what this has provided for me now. This has actually provided a whole bunch of points. And I think this is a little bit easier to think through because we are going to have to now somehow get this into the xy plane. So the thing to remember is that x equals r cosine theta, y equals r sine theta. So if I want to now start coming up with x, y coordinates, I need to use this kind of relationship. And so now I can tell what the value of r is for different values of theta. So I'm going to set up this little table of, let's see, let's take theta, r, x, and y now. And we're going to have to just be a little careful in how we think through everything. So starting at 0, so I know when theta was 0, we said that my r was equal to 2. So now if I plug in 0 and 2, so I'll have 2 cosine 0, 2 cosine of 0. 2 cosine of 0 is going to be 2 times 1, so that's just going to equal 2. So that's going to be my x coordinate. And then I'll have 2 sine of 0, keep writing theta instead of 0, sorry, and that's just going to equal 0. So there's like my first xy coordinate pair, okay? And so now I can continue this pattern. So next I'm going to have, when we had theta was pi over 2, I had that my r was 3. So I'm going to have that my x coordinate will be 3 cosine pi over 2. So that's just going to equal 0. And then 3 sine of pi over 2, that's just going to equal 3. So my next coordinate pair is going to be 0 and 3. And so I can continue this just on down. So I can continue this for pi, 3 pi over 4. Let's see, I can do this for 2 pi. Okay, so let's see, at pi, so this is going to become, at pi, this is going to be 2. At 3 pi over 4, this is going to be 1. And at 2 pi, this is going to be 2. Okay, so now I can plug everything in. So I have 2 cosine pi, so that's going to give me -2 and 0. And then here at 3 pi over 4, this will be 0 and -1. And then this is just going to start to cycle back through. So this will be 2 and 0. Okay, so now I have a bunch of coordinates, so now I can actually do something with this. So let's make some space. Okay, and so now I can set up my x and y axis, right? And so let's see, I'll have this go out 3 in each direction, and I can just plot my little xy coordinates. So I have 2, 0, so here's 2, 0, and then I'm going to have 0, 3. I'm going to have -2, 0. And then let's see, I come back up to 0, -1. So I have something that looks like this. Okay, and so then I should be able to kind of flesh out a graph. And of course, you can grab a few more points as you need, but I can just kind of sketch now an approximate graph. Oh, that is a terrible looking graph. Okay, wait, sine. Okay, and so now I have my graph from this. So it is kind of a lot of work to go through and do all of this, but you can see what goes into it. All right, and so that brings us to the end of this video. So I'm going to leave it at that, and I will talk to you guys in another one. Bye.